Hi again. In the last tutorial we saw how to read from the SD card a binary file and to write back a binary file to the SD card, and we saw it on the SD card in the PC, everything that was written. In this video I want to show you how to manipulate the text so we can write it on the SD card. First I'll remove the out DMA file and put my SD card back in my board. And let's look at the software. To show you how to use text, I'll be using the check data function that we used in the DMA tutorial. Here we actually read the RX buffer, which after the software was done, this is where the DMA put the data in the DDR. Now we compared the RX packet to the TX packet and print a message if either it's okay or we have an error. Now I'll be using this function to show you how to work with an SD card with a string. I will print the string here also in the SD card, so I will get a log in the SD card as text file. From the message we need to generate a string, so we'll add char, we'll call it print string, and like always we need a size for it, so integer print string size. Okay, now we'll take the message as it is, duplicate it, and instead of using the xil printf function, we'll use the s print function, which will generate a string from my message. So I'll get it in the string. Now I also need how many bytes I have, and this is what this function returns. So I'll use the print string size equal. And now I have the string here and the size of the string here. I'll do the same for the OK message. And now I have the message in a string. And this string I want to write to the SD card, and I want to do it again and again because I want to show you how you can open a file, write what you need, and close it so it won't be corrupted if a long time will pass between first write and next write. So I'll take the read function, everything that I did here, and we'll change it. Open. First we need a fill struct. We'll take it from here and we'll add it here. And of course we need the results variable, the f result. And we use fill as w write text file pointer. Now this is the pointer that we will be using instead of the RFT pointer. Next, we need a new file and we want to open it in always. So the new file will be a text file, DMA log.text, and we don't want to read it, we want to write it. So we'll go back here and we use the open always, because the open always will open a file, will create a file if it doesn't exist, and if it does exist, it will still open it for a write, but the file will still save its data, and of course we want to write. Next, read size. We need the read size, we don't need the data size anymore here, and it will corrupt everything here, but we don't need, instead of the read size here, we call it old file size, and it's an integer. And again, this is the variable for the file with the object and the object size. Now this is how much data is already written in the file. So we need to address the pointer of the file not to 0, but to this variable. Okay, now we don't need a read. Now we want to write. So we'll change to write. And we'll use the file pointer. Now we want to write the string that we generated here, so we put it here, and the size is the print size. This is how much data we're now writing to the file, and we need the unit BW, as we did before, and we want to close the file, and actually that's it. So we checked the data. If it's not equal, we print an error message and generate an error message, and we comment, because here if I use if I return, this will stop. So if I have an error, I don't want to stop, I just want to print it. So we print. If there is an error, we print an error message. If it's okay, we print an okay message. And in both cases, we take the message, we save it in print string variable, and we open the file, we go to the end of the file, we write the string, adding the string to the file, and we close the file. And this will do to every single file here. So after we wrote a text file, I want to read a text file. I want to show you how to read a text file. Actually, it's very simple. It's very similar to the read we did before. So we'll take the read before and we change it to read the text file. And after we generate it in the check data, and let's start checking. First, we need to change the name of the file. We now want to read the DMA log text file and not the IDMA read. So we'll change this. We still want to read it. We can use a different file, but this is the last file. But I'll do it this anyway. I'll change the RFP to rTextFP, and after the check, I'll replace everything here with the our TFP. 1, 2, 3, 4, 5. That's it. Next, we have the read size. We will get how many bytes we have in this file. We don't need the data size anymore. And we point the pointer to the start of the file. Next, we'll read the file, but not to the TX buffer. Now we will use another buffer. We call it read log file. We'll have it here. We still use the read size because this is a new one. It's here, and the BR is still the same BR. It doesn't matter. Next, we read it to the read log file buffer, and we close the file. And the last thing we need to do is to print. We'll add a log. We'll add a message showing this is the log file. And since this is a character buffer, we can just print it without the parentheses, without anything else. We can just use it as it is and put it here, and it will come out. That's it. Now I can compile and I can run it. And I'll clear my term. And now let's start running till the file generation. Here we generate the data. Here we read from the IDMA buffer, as we did before. Now let's work the DMA, and the buffer, the R buffer was changed, so we need to bring it again. And here it is, and we write it to our out DMA file. And now let's go into the check data function. Here we'll go to the buffer changes. Here are the two buffers. And here we have the data at the input and the output. Now we compare the data and it's right. So we print the data file. Next, we have the print size and we have the message in the print string here. And we can write it to our file. We open the file like we did before. We check the old size. Now it's 0 because nothing was written there. And we write the first 18 bytes and we close the file. Now we go back. Now for the next message, we check the 2 compared to the 2. and it's not wrong, it's okay. So we print the message, here it is, and we write the next data. We have the print size is 18 and we have the string here. We reopen the DMA log text, everything is okay. We check the size. Now the size old data is 18 because we have the previous message. We'll write the new string and we'll close. The next one, again the same, but I want to show you here that now after we have the buffer, we reopen the file, and when we check the size is 38 because we have two messages here, and we'll add the next one. And so on. So we'll finish this function, the check data. Here are all the prints. And we came back to the simple polling example. Now let's read. We reopen the DMA log text file, this time in read mode. Everything is okay. We checked the size, and the size is 980 bytes. That's all the messages. So this is the buffer, and now we have the buffer, the read log buffer. We can see it here. And once we read it, we see that the data, and this is the characters of the data, 44, 61, 74, 61, by the way 61 is A, 20 it's a space, 48, these are the messages here. So everything is here. We have it all in the buffer. We can close the file. We'll print the log message here, and in one print we have all the buffer. Here is the buffer from the file, and here is the buffer from the check data file. And that's it. We can go back. We successfully finished the DMA transaction. We unmount the SD card, and we finish the software. After we finish the software, we can take the SD card out of the board and connect it to the PC. And here we have the IDMA bin for the input data, the out data, as we know from the last tutorial. And here is the text file. And if we look at it, we see all the messages are printed here, one after the other, like we expected it. In this tutorial, I tried to show you how to read and write from an SD card, either binary file or text file. I hope that you find this tutorial useful. Thank you and goodbye.